Welcome back to the National Weather Service video series on Washington flash flooding and burn scars. This is Greg with the National Weather Service in Spokane. This is part 2 of this video series, the importance of thunderstorms in relation to burn scar flash flooding. In part 1 of our video series, we discussed 3 elements of flash flood risk on burn scars. We are going to discuss rain rate quite a bit in this video. Hydrologists and soil scientists have discovered that approximately 1/4 inch of rain in 30 minutes or 1/2 inch of rain in an hour can initiate flash flooding on a burn scar. Debris flows can begin with even less rain than that. In either case, this is not a lot of rain, but we don't often see these rain rates on a typical rainy day in the inland Northwest. We need thunderstorms to produce this type of short duration heavy rain rate. Flash flooding can also occur with less intense rain rates over a longer duration. However, these rain rates aren't particularly common. On rare occasions, a Pineapple Express or an atmospheric river can produce 1.5 inches of rain in a 12 to 36 hour period, but the arrival of a Pineapple Express is often accompanied by a rain shadow east of the Cascades. So places like Chelan, Carlton, and Omak are usually in the rain shadow and less susceptible to the amounts exceeding 1 inch in 2 hours or 1.5 inches in 12 to 36 hours. With the rain shadow in mind, the short duration, intense rain thresholds seem more likely for our burn scars east of the Cascades. For that reason, the National Weather Service is most concerned about heavy rain associated with thunderstorms. This graph displays the average number of thunderstorm days per month for central and eastern Washington. On average, thunderstorm chances increase in April, peak during the summer, and decrease quickly by mid-September. This graph suggests that our thunderstorm season in the inland Northwest is about 5 months long. For residents of burn scar areas, it will be more important than ever to monitor the weather. A forecast for thunderstorms should be taken seriously, but not all thunderstorms will pose a serious flash flooding threat. Thunderstorms come in many shapes and sizes. Some thunderstorms generate very little rain, while others produce heavy rain very quickly. Thunderstorms that produce heavy rain require 2 main ingredients: 1, rich moisture, and 2, instability. Slow-moving storms can also be an important element of heavy rain production. To illustrate the role of storm movement on flood potential, check out this animation of a fast-moving thunderstorm scenario. Fast-moving storms spread rain over a large area, limiting rain amounts over any one watershed. The scenario generally yields a low flash flood or debris flow risk. In contrast, a slow-moving thunderstorm concentrates heavy rain over a smaller area. Slow-moving storms significantly raise the risk for flash flood and debris flows. Perhaps the most complicated flash flood scenario is the training thunderstorm scenario, where multiple storms track over the same area repeatedly. The cumulative effect of heavy rain can lead to the development of flash flooding or debris flows. In the Pacific Northwest, the combination of moisture, instability, and weak upper-level winds required for slow storm movement is the most common in June, July, and August. When the atmosphere has the right combination of ingredients for heavy rain, the National Weather Service will issue a flash flood watch. Burn scars have lowered our threshold for flash flooding in Chelan, Okanogan, Ferry, and Stevens counties. During the next few years, residents of north, central, and northeast Washington will probably see more flash flood watches. Being aware of the weather will be more important than ever. For a description of National Weather Service watches, warnings, and advisories, view Part 3 of this video series.